Hello and welcome to this presentation on micro frontends. So who am I? My name is Jesper Brännström and I work as an architect and a tech lead at Forefront Consulting. And we've implemented this pattern at Trygghetsrådet. And with me I've had a team of veritable superheroes and we've together come all this way. So I'll try to guide you on our journey that we've come on so far. But what challenges led us here? I mean, you don't usually start with a solution. We've actually had a number of issues that led us to this sort of solution to our problem. And so yesterday, the different initiatives looked like this. We had multiple parallel initiatives that were looked at as platforms. But we've come to the conclusion that it's going to look a little bit more like this in the future. So instead of separate applications, we are actually building one big application. And all of these small different initiatives must work together. And they're going to occupy the same space. And so this is the way it's been looking so far. These different colors represent different applications. And you can see that they actually have different shapes. And so our goal is to make the user experience more consistent and more coherent. And also somehow to reach development scalability when we have these different initiatives where they're going to spread out over time in terms of complexity. And so how can we actually make that into one, a more simple way to develop? And so our goal is to make something a little bit more like this instead. So it's still going to be different applications developed by different teams, but it's going to be more consistent from the user's perspective. And so this is probably something that you've seen a lot in big development organizations. When you have different teams, oftentimes different teams implement the same thing over and over again. It may be things like login or different toasters or any kind of feature really. And so we want to be able to avoid implementing the same thing over and over again. And so the thought here is if we can implement something systematically, then we can also change it systematically. And so the base focus is to create customer value instead of focusing on these different technical initiatives. We also have another issue, and this is not actually specific to micro frontends per se, but it's a problem that we've had at this customer. And so we're using Episerver, a CMS system. And the goal is to make this somehow a little bit more easier for the users, for the editors. And so this image here on the left is perhaps a little bit difficult to understand. We need to somehow make it easy to use. And also there's a goal to widely increase the number of users over time to scale to the millions rather than the tens of thousands. And so we've usually had the normal perspective of either being logged in or logged out. But we're starting to look at this more like a scale where you may access some features depending on where you are in a flow rather than just being locked out of all of it. And so viewing this more like a scale means we need to change on how the login flow is used and implemented across the different applications. And if we implement this once, again, we can change it in the same way all over the place. But what are micro frontends? I mean, what have we been talking about here? So briefly, you can look at it as when an application is composed of parts owned by different teams. And most importantly, these teams are independent, autonomous, and they work end to end. And we'll get back to this in a few minutes. But what alternatives are there? I mean, there are always different ways of implementing something. And so let's have a brief look at the different ways we could approach this before we go on and look at our approach as to how we did this. So first out, and perhaps the easiest solution, is to simply link different applications together. And so you go from one URL to another, and you simply go from one application to another. This won't actually help any of these challenges we've had. You'll still have the different inconsistent and incoherent user experiences. And so this isn't really a solution for our team. You could also do it at build time. If you've worked with front-end development, then you're surely familiar with this middle part here. You can simply say in your node dependencies that you depend on specific versions of different apps and package it at build time. But this actually violates one of our core principles, that the teams need to be autonomous and independent. And so if my application lives in a parent application, then I'm dependent on that application being deployed again for my application to be deployed. And so we won't ever reach independent workflows that way. So unfortunately, that's not the way to go either. Now you could do server-side rendering, and that's not an issue. But one of the problems with that is you don't really reach this single spa-like fluid experience serving everything from the server side. You could do something like both, doing it runtime and server side, but we've been looking more at a runtime integration, and so doing it all live. But what does that mean? So one of the things we need to think about is the impact on the different development teams when we do this. And so we didn't start out with micro frontends, we've come to that down the line. And so whatever we do needs to be low impact so that they don't need to spend months implementing whatever solution we come to. And again, they need to still be independent and autonomous. And importantly, the experience needs to be spa-like, fast, fluid. And so there are different alternatives here, of course. Runtime-wise, you could look at something like web components or custom elements or even different frameworks that's been developed for this. We've chosen React for various reasons, and we'll discuss those later. But for now, we can just keep in mind that we've chosen the runtime integration way of doing this. And so what's this? I mean, you can see the different colored squares here on the screen, but we'll focus on the gray one. We'll call that one the app shell. And so what are the responsibilities of this app shell? We're going to look at something called UI composition. We're going to need what different applications are going to be composed together to be able to create a specific view. And also, there are going to be various common concerns that we're going to want to implement once and only once. For example, top navigation, login, logging, and so forth. We're not going to need to implement that for each and every application. There are also going to be various global features. A toaster, for example. We can use the same one again and again instead of having it packaged in every application. There's going to be cleanup sometimes. For example, if we're moving from one view to another, there may be some clutter in the window and global space that we need to remove before moving on. And so that's also a responsibility of this application shell. Communication. And this is actually communication between the app shell and the different child applications. Not necessarily communication between the different micro frontends themselves. We can see this as an extension of the microservices concept. And so when you look at communication, we can use the same sort of principles on how to communicate. And we'll look at this more in depth in a while. So how does a micro frontend get into this app shell? So we'll start looking at this from a more high-end sort of view. So starting out, we can say that an application is this yellow square here. And we're building it. We're spending some time, a few sprints on it. And once we're happy, we can start deploying it. And so we do our various checks, and running our unit tests and so forth, and making sure that it's built correctly. And when it's built correctly, we can put it somewhere. And we're putting it in some kind of storage. And once it's been put into a storage, we can point to its location. And so here we're using a kind of map to point the way to where it's placed. But this is kind of a high overview of how it works. So let's go a little bit more in depth on how it actually works. So let's say we have version 2 of some application. Still, we're using the yellow square as representative for our application. So once we're done, we're merging a branch into our main line. We're running our CI/CD pipeline, and in our case, we're using Microsoft Azure Pipelines to do this. And once it's done, once it's run all the various checks and whatnot, it's going to generate a package that it's going to put somewhere. And in our case, it's a blob storage. And you can see here above the blob storage that there's a URL representing where it's available in this blob storage. After that, it's going to need to notify our CDN, and we're using Fastly for this. And I've also used, you see this lightning bolt representing Azure functions. It doesn't actually necessarily need to be Azure functions. It only needs to somehow notify Fastly that there's a new version of this application once it's been deployed. So the idea is, if we have a CDN for our different applications, we can, on the fly, direct from one version to another once there's a new version available. And so in the next step, again, we have this yellow square representing version 1 of our application. And when the app shell says, OK, I want you to retrieve this application for me, then it's going to go through Fastly. And if there's a new version and Fastly can toggle between them, we can easily send the new version once it's available. And so Fastly gets version 2 in this blob storage location and sends it back. And before moving on, we can look at the bottom left here. There's a script tag here where it says system.js import map. And so this is the system.js implementation of import maps. This is a new feature available not in all browsers, although in most of them, but using the system.js implementation, it's widely available across all modern browsers, and so that's why we're using that one. It may be the case in a few years that it's a standard implementation, but for now, since it's not, this is what we're going with. And so the most important thing to remember about import maps is that it allows us to retrieve applications from somewhere on the web rather than from node package management during build time. And so this is what enables us to do this during build time. We actually had a more convoluted approach to this a few months back, but we came to the conclusion that we didn't actually need that much complexity in order to get this work. So our initial idea was to update this import map on the fly in the application using Azure App Configuration and even abstractions over WebSockets. But it ended up being much more easy to just abstract this behind Fastly instead. And so that's the approach we're taking right now. So the idea is, once we've deployed something from our CI/CD pipeline, we simply need to somehow notify the app shell, or at least get the new application that we've deployed, and we're done. So let's look at some of the app shell responsibilities. I've listed them here, but let's look at them one by one. And so again, this is an image of the import map. And it's simply an object representing the different application that's available somewhere on the web. And you see here the first two imports represent our different applications developed by our teams. But you can also see more common dependencies like React, React DOM, and even a common component library. So let's look at those. If you look at micro frontends material available online, it's often frustratingly brief and vague. It's almost as if there's a lot of people actually haven't been able to do it. So I put in this slide this is actually something that we're actually using. We've switched out a couple of the properties, but this is actual code running. And as you can see, it's very short, it's not complex, it's only a few lines of code making this work. And so I'd like to highlight this line here, which lazily loads an application. And where it imports the name, that name maps to the import map, which then retrieves the application from somewhere on the web, in our case, in the blob storage through Fastly. We can also look at the error boundary and suspense we're using here. It's important to make sure that if there's a kind of error in any of our application, that if they blow up, then we can still use the rest of our application. So let's move on. We're going to need to have a lot of common dependencies. We've chosen to use React in all of our application, and so that means that there are a lot of dependencies that we're going to use over and over again. All of our applications are going to use React, React DOM, and a few more. But there are also going to be a few common components. For example, we have buttons and components like that are always going to look the same. And again, if we implement those systematically, then we can also change them systematically. And these are marked as external dependencies in our packages. So if we retrieve them once, then we can reuse them through all of our different micro-frontend applications. So we're using something we call the common component library. Now we're using a button here to illustrate, but there are a vast amount of components available here. And so again, if we import this button, whether it be a micro-frontend 1 or 2 or wherever, it's going to look the same. Now it could be the case that if we version these, if we update a button, for example, and change its appearance or its behavior, we could use one version in one micro-frontend and another in another frontend. And that could be okay. It may not actually need to be super consistent all the time. The backside to that, of course, is you could run into various issues with bugs and so forth, but this actually tends to work pretty well. But of course, it also needs regular effort and sync work between the different teams to make sure that they're all aligned on how these things are supposed to work. It could easily be the case otherwise that a rogue team does something to a component that doesn't align with what everyone else wants to do. And so you need to work on the development communication to make that work. Speaking of communication, more on the technical side, so we need to be able to talk from the app shell to the different micro-frontends. And so that might look like this. Let's say, for example, in a micro-frontend that we click the login button. We haven't actually implemented the login feature in our micro-frontend. That's a feature we want to be able to develop once and be done with it. And so we can send a message to the app shell that can trigger that functionality. So we're using the built-in browser message dispatch to do this. And so here at the top, you can see the micro-frontend dispatches an event on window where it says, go to login clicked. And then in the app shell, we can subscribe to that event as we please. And you'll notice also that we've used from event here. In this case, we're using RxJS observables to subscribe to this. The advantage to this approach, in other words, is we can use different kinds of libraries in different applications if we want to. We're not all required to use the exact same way of communication. A few approaches that we actually didn't want to go with is, for example, to use the mediator pattern. We could have, from the app shell, injected a mediator observable, for example, that everyone could use, like one channel to communicate with. But that would impose some restrictions that we didn't want to go with. And again, just reminding you that we're just extending the concept of microservices to also include the front end, to have the entire vertical. And so we're using the exact same principles of communicating here, so there's nothing new. And in this case, we're leveraging the browser's messaging functionality to be able to communicate easily. So let's talk a little bit about UI composition. And so we have a CMS where it has different kinds of pages, and editors need to be able to put things together. And so this is what a response might look like. So we have some content, and it's going to compose different applications together. And these applications, in turn, might also have content. And again, these micro-frontends map to our import maps. And using those, they're going to get them from the web and put one page together. And so this is what UI composition might look like in a few months. So we have some kind of start page where it just has some kind of link into a major application. And again, we're using these yellow squares to represent our actual application. And so we're coming from some page more public and going into one specific feature. And so the teams representing this yellow square, they don't really need to think about the start page or the offer page here. They only need to think about their actual feature, not necessarily on how it's going to be available on the web. And like you can imagine, there's actually a lot of work making this into a complete whole and a holistic approach that actually works well from the user's perspective, and also to be able for all the teams to understand on how things work together. And so this is one image that our UX teams are working with to be able to see how different flows work together. So this means that this actually isn't only a technical problem, it's also a UX problem, and it's also an organizational problem. So that was a brief overview of the different app shell responsibilities, but we've actually had some forks in the road in terms of the technical approaches that we've taken. And so let's look at those. No, yes. So there are a few things that we decided against, and a few things that we decided to go for. And so the top left logos here, Pyral, and the blue one is the logo for SingleSpa. These are actually frameworks for micro-frontends. There are numerous downsides to these frameworks. They made it too complicated, too convoluted, and frankly, a little bit too hard for our purposes to work with. We didn't need those. And the middle icon is the icon for web components. This is actually a very valid approach. Using web components, you could use any popular framework and be good to go from the different teams. For example, one team might use Angular, but another one could use React, or another one could use jQuery or whatever. It wouldn't actually matter. And there are a number of reasons why we didn't go for this. Number one is it's actually hard to get the package size down a lot. If I need to retrieve Angular and React and various other frameworks, the package size is going to be very big. And again, if we're leveraging that all developers already use React, it's going to be easier to align everyone on their work. Remember, we're using a lot of these, we talk a lot to each other, and so that makes it a little bit easier. I've also crossed over the RxJS logo. And again, we mentioned this briefly during the communication part, but we didn't actually need to enforce RxJS usage and a mediator pipeline kind of approach on all applications, even though this is a popular approach among many implementing micro-frontends. And lastly, and perhaps most importantly, we've crossed over the rocket. So we wanted to do something that wasn't overly complex. We wanted to do something that's fairly simple. And so our image of what we've built is something a little bit more like this tree cottage. It's simple enough, but good enough for what we need. And so our main two pillars on what makes this work are we're using a React-specific approach, and we're using import maps to be able to do this on the fly in the runtime. And we've had a number of challenges, like you might expect, during the months that we've implemented this. And the first one is communication. And I'm not talking about technical communication here. I'm talking about communications between teams, within teams, and between the organization and the development teams, and actually making sure everyone actually agrees on what should be done and in what order. Priorities when implementing after the fact. We didn't start out using micro frontends, and so if we're implementing this after the fact, it's easy to say, oh, we need to finish these features first before we're doing the few things that we need to do to be able to fit into the app shell. And the negative side about that is, of course, the longer you wait to implement everything systematically, the more expensive it's going to be down the line, the more you wait. Testing. If we have various different features aside from each other, each team is going to be responsible for their single thing working using unit tests, integration tests, and application tests. But we're also going to need to make sure all these things work together. And so that can be a little bit difficult to make sure it works correctly if we have different teams where we don't necessarily know what kinds of things that they have that they need to work together in different ways. Alignment in terms of making sure that everyone understands what different parts and how they're going to work together. For example, if we have one login solution, how should it work? Why should it work that way? How should the user flow be? It could be that one team has one version in their minds of how it's going to work, and another team has a completely different view. And so we need to work continuously on that image to make sure that we're all aligned and have the same goal of what the end product is going to be. And so the next point is performance. This is something that we've worked a lot on and that we're going to continue to work a lot on. This is one of the main downsides using the micro frontends approach. Is it's very difficult to make sure to keep up the speed, especially over time. It's very easy for various teams to increase their package sizes over time, and even forgetting to make sure that we don't retrieve our common dependencies more than once. The speed of which the application is sent to the browser and when the user can start using the application is very indicative of how often they're going to stay and use our different features. And so we need to work continuously on that. There's also been some problems keeping the boundaries, and by that I mean it's sometimes difficult to know if a new feature or some functionality is going to be placed in the app shell or in a different team's initiative. And so this will be a little bit more easy if we're using something like domain-driven design, where we may know our bounded context, but that may not always help with some of the more sophisticated technical issues. And this is something we see again and again, that it's not always clear-cut on what belongs where. Surprisingly, explaining the app shell concept is one of the more difficult things that we've had. Although simple in itself, there seems to be something that when introduced after we've had major initiatives, it's a little bit hard to understand what my application, my team's features, what their place is in all of this. But again, communication being one of the most major challenges, you simply need to keep at it, and it'll probably turn out well over time. And we've also had some issues with Conway's law, the law saying that a system is inevitably over time going to reflect on the way the organization's communication is built. It may be the case that we see this as inevitable, but we can actually work on continuously changing both the organization itself and the systems. And hopefully we can make something that is actually a little bit more easy to understand. And so wrapping this up, there are a few prerequisites to be able to make micro frontends work. This is something that works well for some kinds of problems and not so well for others. And so the main one is starting out that you have multiple teams developing features for one coherent solution. You are probably going to need a UX team as well to make sure that everything works in a coherent way, not only user experience-wise, but also main features like components and flows and so on. Communication has continuously been one of our major problems, and at this customer it's actually working very well already. And so if you're experiencing bad communication between different teams, then you may need to start working on this before implementing this technical solution. We've had a lot of help having a maturity on the architecture side, both in terms of the technical side, but also continually having a dedicated architecture team between these different development teams, and the architects always talking to each other to make sure everything is aligned. And there's no way you're able to do this without having a DevOps and CI/CD pipelines and automation in place already. It's just not going to work well. And as a friendly reminder, everything we're talking about is various kinds of trade-offs, and so I'm not claiming that this is a silver bullet. It just tends to work very well for some kinds of problems, especially the one that we're at the moment with this customer. And again, closing off, the app shell speed is something that you're going to need to work a lot on and keep working on, and even monitoring to make sure that you're not slowing down over time with all the different teams and various initiatives. So that's it, and I thank you for this time. Any questions?